Okay, that's fine. Hello, good day, everyone. My name is Ali Sadiq, and I am from Nigeria. I am the founder of EcoCycle, an organization focused on providing solutions to address climate change, especially targeting empowering young people in communities. Today, we're going to have a very detailed explanation on climate change introduction. And I look forward to having a wonderful session with all participants. Thank you. So I'm going to share my PowerPoints now, and I believe it's going to be as interactive as possible. So permit me to please mute my camera, turn it off while I share my screen. Okay, so like I made mention earlier, the topic is Introduction to Climate Change Science. And today we're having a lot of young people who are really passionate about climate change, wanting to, contribute their own quota towards addressing the problem of climate change. But understanding the sciences and the basics is really a very important part of the advocacy or the activism journey for every young person. Today we're going to be discussing introduction around weather, climate, greenhouse gas effects, human influence on climate change, significance of greenhouse gases and their primary sources, climatic changes during industrial revolution, the effects of climate change on surface temperature, precipitation, ocean pH. We'll also be talking about sea level and extent of Arctic sea ice. Basically, when you talk about weather, because weather is a background to climate change, weather is a phenomenon that has been altered or has affected the gross climatic situation. So in basic terms, weather is just the state of the atmosphere. And the sky above you, where you have your rain formation, where you have your oxygen, that is what you consider as your atmosphere. But then the state of this atmosphere determines what is the situation of the weather at that point in time. But it's a short-term situation or state of the atmosphere. And most of the times, this weather is being measured by the pressure, the wind, the moisture, the cloudiness, the precipitation. All these are temporary situations or states of the atmosphere. Then climate is like the long-term state of the atmosphere. So it's more of like a long-term state of, so it's more of a long-term weather state. So when you have a short-term state, it's a weather, and then when you have a long-term state of the atmosphere, it's climate. And this is the word climate was actually gotten from Greek word klima, and which means inclination, and the average period to determine a climate is about 30 years, 25 to 30 years averagely. Some sciences may have it as 25, some may have it as 30, some may have it as 35, but 30 is the average period of years to be able to determine climate. And this climate changes in climate situation is what we are experiencing today about the issue of climate change. And that is why you cannot have the IPCC report without having to have, estimates of over 30 years prediction of changes in the weather and the conditions of the atmosphere. So some basic elements of weather and climate. Temperature, which has to do with the degree of hotness or coldness of the atmosphere, and this temperature could actually vary by various factors. That is why today we're saying the world is about 1.5 degrees, is heading to 1.5 without strong efforts to mitigate climate change. We might just be reaching, we might possibly get to 2% rise in global temperatures. This has a direct effect on local weather or local climatic temperatures that is within particular regions or the microclimate of a particular place. Radiation. In the course of this presentation, we're going to understand how radiation has a role to play in the climatic system of the Earth today. And the radiation is actually the heat from the sun, but the radiation drives all forms of energy on the Earth's surface. And without the radiation, the Earth might probably be too cold for human existence, but an average level of radiation is optimum for human survival. But when there's an excess amount of radiation within the atmospheric cycle or within the Earth's surface, it becomes a problem for humanity. Then air pressure, which has to do with the pressure, and sometimes where you have some form of some devastating, some disasters or hazards, you find out that they are being resultant as a result of some of either low pressures or high pressures. Like example, cyclones. Most of the times when cyclones happen, you find out that there's a very high level of pressure, which has a way to influence movement, humidity, the atmospheric, the amount of water present, greenhouse gas effects. The picture you could see here is a pictorial representation of the greenhouse effect, how it comes down. When you look at the sun, it brings down radiation. That is the heat from the sun to the Earth's surface. Naturally, without this radiation, the Earth is unable to be conducive for human survival. But there's a balance that happens when the land surface absorbs this radiation, the ocean surfaces absorb this radiation, and the atmosphere absorbs this radiation. The excess radiation has a natural effect of going back to the atmosphere or out of Earth's surface, hence enabling a balance that makes the atmosphere or the Earth's surface not so hot for human survival and not so cold. Now, naturally, this is what is referred to as the greenhouse effect. The incoming radiation coupled with the balancing of the radiation as a result of, again, another outgoing radiation, which creates an optimum temperature level within the Earth's surface. So the distortion of this naturally occurring incoming and outgoing radiation has resulted to what we experience today as greenhouse global warming due to greenhouse gases resulting to climate change. And most gases that cause or emit or contribute to this global warming is, we'll talk about that shortly, but carbon dioxide, methane, nitrogen, oxide, chlorofluorocarbons, and so many more. This became really much more pronounced during the Industrial Revolution era, where the world was clamoring to become much more industrialized. Companies were enacting, productions were escalating, technologies were becoming much more used for production, and then this exacerbated emissions of these greenhouse gases. And that was the beginning of the problem, which has affected the greenhouse gas effect. Okay, so in the section 2, we're going to go deeper into some of these greenhouse gases and talk on how these greenhouse gases are emitted and what they contribute or their consequences. So there are primarily 4 greenhouse gases, even though they are more than this, but some of the most devastating, some of the most hazardous to the climate change are 4. And one of them is carbon dioxide. Carbon dioxide today is a problem, is one of the most sourced or most emitted greenhouse gas globally. Secondly, you have the methane. Methane is even much more potent than carbon dioxide, but carbon dioxide remains for a longer period of time in the atmosphere than the methane. Nitrous oxide, halocarbons, which are a group of gases containing fluorine, chlorine, bromine, amongst others. I didn't explain the sciences of how these greenhouse gases cause climate change. So when activities are being carried out by industries, burning of fossil fuels, burning of firewood for cooking, use of coal to power industries, there is a huge amount of emissions that release these gases into the atmosphere. This atmosphere moves up to a part of the atmosphere called the ozone layer. Now, the ozone layer absorbs these greenhouse gases and forms an envelope-like structure or an envelope-like surface covering the ozone layer. Now, the ozone layer ordinarily helps to provide the space for the outgoing radiation after the Earth has absorbed the optimum heat required. The ozone layer allows the space for these emissions or this radiation to go back to space. But when these greenhouse gases create an envelope surface on the ozone layer, they block these spaces. Now, what happens? There's a ripple effect. The ripple effect is the heat coming from the sun, which has gone into the atmosphere, gone into the surface of the Earth, and is expected to create a balance by remitting back the unwanted radiation, can no longer pass the atmosphere through the ozone layer due to the blockage by these greenhouse gases that has been emitted mostly by human activities. It then contributes and ensure or blocks this radiation. Thus, these gases or this radiation have to now remain within the Earth's surface, automatically increasing the temperature of the Earth. This is what causes what is called the global warming, because the radiation that is meant to go out of the Earth's surface can no longer go out easily. Definitely, there must be an increasing heat or increasing temperature on the Earth's surface. Basic sources of greenhouse gases. The carbon dioxide I mentioned earlier comes from burning of fossil fuels, which are being used in transportation, building, manufacturing, deforestation. Most of these activities releases carbon dioxide. For the methane, the agriculture, the landfills we see in our communities, natural wetland processes, when these processes are altered or there's an issue or there's unsustainable practices within these angles, it then results to generation of for example, waste. Waste has a very is a contributing factor to methane, because the gases released in waste, especially in landfills, in open dump sites, directly contribute to the generation of methane, which is highly potent. Nitrous oxide, the use of fertilizers today in farmlands is on the rise due to the demand to meet the food needs of rising population. But this process releases nitrous oxide, which is really also devastating in terms of greenhouse emission. Then the halocarbons, especially in industrial processes, refrigeration and the rest, they also releases the halocarbon gases. Human influence on climate change. Humanity are responsible for the climate change situation today, even though there are other natural factors which are uncontrolled by man. But when you look at the industrial era until now, there have been a devastating increase in the amount of greenhouse gases in the atmosphere. There has been an increase in temperature level of the globe or the world, and this has resulted to devastating climatic consequences, which is referred to as the climate change today. So human activities have been of utmost contribution to the climate situation today. I spoke about the envelope that forms on the ozone layer, which avoids or prevents the radiation from going out of the Earth's surface to create a balance. In what ways have humans contributed or affected the climatic condition of the world? Burning of fossil fuels. Today, industries, countries, corporations depend on fossil fuels as their major sources of revenue, as major powers to drive their industries, as major sources of energy. And these practices have been neglected in terms of the environmental and climate impact, but they are more focused on the economic and the profit values of using fossil fuels. But evidently, we have seen how fossil fuels contributes to the climate change and how it has a very significant role in affecting the future climatic situation, even resulting to much more devastating consequences. Across the globe each year, we now burn over 4,000 times the amount of fossil fuels burnt during 1776. This is to show you how the Industrial Revolution have massively exacerbated human burning of fossil fuels to meet needs. Agriculture. Animals today contributes a huge amount of methane to the climate. In terms of, that is why a lot of advocates also advocate for less consumption of meat, because through some of this fermentation of these ruminant animals, they release methane gases from their poo or their urine. They also release some form of greenhouse gases. In 2005, agriculture emitted 5.1 to 6.1 billion tons of CO2 equivalent, contributing to 10 to 12% of all anthropogenic greenhouse gases emitted. So the role of agriculture in contributing to climate change cannot be emphasized. It has a very significant role, and that is why the need for sustainable agriculture becomes need while we try to meet the food demands of a growing population globally. Trees also play a key role in terms of sequestrating carbon or absorbing carbon. So when trees are being cut down due to deforestation activities for economic values and purposes, it creates, it releases this already absorbed greenhouse gases into the atmosphere, which hence also contribute to global warming. Urbanization, due to the increasing global population, trees have been cut down to develop buildings, to develop communities, to build roads and infrastructures. So massive urban growth can result to increased deforestation, habitat destruction, and greenhouse gases emissions. When you look at the vehicles in your community 10 years ago and now, there have been an increase in amounts of vehicle users. This all as a result of increasing population are affecting or contributing to greenhouse gas emission and global warming. The waste sector, I spoke about this earlier. It is responsible for about 20% of human-driven methane emission globally. And when you look at waste in developing countries, is a major problem affecting a lot of communities. In developed countries who have proper infrastructures for managing waste, they still face challenges of waste, even though not as pronounced as those in the developing countries. But climate change is a global phenomenon that emissions from one country affect the whole country or affect the whole world. So it's not about this part of the world being able to manage their waste sustainably and the other parts of the world not being able to sustainably manage their waste. It's about achieving a climate action that is equitable and ensuring that no one is left behind. Organic waste also contribute in terms of their decomposition, food waste, amongst others. Okay, so we're moving to the section 3 of this presentation, and I'm sure you are getting to understand the basics and the links between human climate change and devastating impacts of climate change on humanity, industrial revolution and climate change. Now, before the Industrial Revolution, the world was a safe place, a calm place, even though less amount of industries, development, technology. But immediately the industrial age came where the world began to become much wiser to leverage its resources. The burning of fossil fuels such as coal, natural gas, oil began to escalate. Humans began to understand the value of using these resources to meet their needs. It was a breakthrough, but a breakthrough that forgot to address the consequences or the future impact of their actions. And this was the story of the Industrial Revolution and how it has affected climate change. Impacts of Industrial Revolution and climate change. Glaringly, when you look at the statistics, in 1750, there were about 280 parts per million of carbon dioxide in the atmosphere. But in 2005, the levels of carbon dioxide had risen to about 380 parts per million, an increase of over 1/3. Now, as human population continued to grow, increased industrial activities and energy usage has also expanded dramatically. And the more, much more sophisticated technology comes, the more the utilization of natural resources are being carried out by countries, by corporations, the more dependent we get on these natural resources, the more the amount of greenhouse gas emissions that the world will generate, and consequently, the more greenhouse gas emissions and the more the impact it will have on climate change. Past and future trends of increasing temperature. Because the global climate change has been distorted, it has been affected, there have also been an increase in temperature. And this is why the world today is clamoring. Young people, countries are coming together to say, we cannot afford a 1.5 or beyond 1.5 degree global temperature. Now, that is because the impacts are uncontrollably devastating. But the statistics have shown us a rise in global temperature right from this industrial era until date. Today, anthropogenic human activities add about 11 billion metric tons of carbon to the atmosphere each year, hence increasing the amount of carbon emissions annually. Looking at the emission trends, you could see that in the early 14th century, 13th century, you could see a kind of a stable fluctuation, even though there have been also some natural factors that brings about this fluctuation, but it has always stabilized within a particular level between above 250 parts per million to about 300 parts per million. But when you look at coming down towards towards the 19th century, 18th century, there is now beginning to be a significant trajectory going up. This is showing you that something has happened. Something has happened in the 20th century. Around, you could see the increase in emissions going even beyond 330, and then in the 21st century, you could see rise to about 388 parts per million. Never has it occurred since the existence or since the beginning of the 10th century. This alone shows you that there was a problem, and this problem was evidently due to human activities. Going to section 4, this shows, this part of the presentation mostly shows us the effects of climate change on some basic parameters, such as surface temperatures. Because the climate has changed, there have been increasing global temperatures in all parts of the world, both the northern and the southern. But climate change has resulted to increasing or to extreming, bringing about extremes in conditions. So the global average surface temperature has increased more than by more than 1.6 degrees Fahrenheit. Surface temperatures vary from day and night. This is due to the regional or geographic positionings of countries and communities and country. So when you look at in terms of the surface temperature, today we are about 1.4 heading to 1.5. Science have shown that we are definitely going beyond 1.5 degrees, and this is to show you that climate change has a direct effect on surface temperature, and this is likely to become much more worse if we continue with the practices that we do currently. Projected temperature and emission trends. The picture or the image you could see shows some statistics of annual carbon emission. And when you look at the annex, you see temperature change. Both have shown a projection that in 20, 30 years from now, we could experience an increase, a rapid increase in temperatures if current trends continue and current human practices continue as they are. This is just saying we need to cut down our emission levels. This is saying we need to change our practices. We need to adopt better sustainable practice, else the world is threatened. Projected global carbon emissions. You could see the left statistics showing projected carbon emissions, that the world is not ready to stop emitting carbon. Because with the statistics, there are possible scenarios that carbon could be reduced with severe effort. But again, there's statistics that shows that emissions might just keep rising because the world doesn't want to listen. Effects of climate change on surface temperature. When you look at, this should be, effects of climate in terms of rainfall. This is rainfall. So when you look at the intensity of rain today we in developing countries, especially around the sub-Sahara, in the African parts of West Africa, or in West Africa, you have cases of increasing floods due to high precipitation levels, unexpected rainfalls, distortions of rainfall duration periods. And this has a devastating effect on agriculture, because agriculture have a stability time. It has a time that it doesn't require rain. It has a time it requires a particular amount of rainfall. But with the climate change, distorting the climate systems and the precipitation or the hydrological cycle, the precipitation system is also affected. And this also brings about erosion, floods, amongst others, most importantly affecting agricultural activities. Effects of climate change on ocean pH. Now, the pH, ordinarily, pH scale is a scale used to measure level of acidity or alkalinity of a substance, which is usually between 0 to 14, with 7 being the average or the neutral. But because of the increasing concentration of carbon dioxide in oceans, now the pH levels of this ocean have been affected. About 30% of carbon dioxide released from the atmosphere have been absorbed by these oceans. As such, this affects the pH or decreases the pH, and the ocean become more acidic. Now, the effect of this is that the species or the aquatic species or the fish or the whales or those aquatic species that depend on this water for their survival can no longer survive. They are being forced to die, or they are being forced to migrate, or it's no longer conducive for them. So that's to show you that climate change doesn't just affect human survival, it also affects the biodiversity. Effects of climate change on sea level. Because of the increasing global temperature, do not forget, there are a lot of regions in the world today that have a lot of ice caps, polar regions to be precise. And because of these rising temperatures, these polar ice caps are forced to be melted. And immediately they get melted, they flow into nearby rivers, into the estuaries, and find themselves in the ocean. This directly increases sea levels. Now, the impact of this increase in sea level is that communities who live in coastal areas, islands within these oceans and continents, within these oceans and seas, are submerged. are faced with floods, lives are destroyed, and properties are damaged. Much more islands are prone or are vulnerable to extinction if sea level rise continue to happen. Now, since 1880, global sea level has risen by 8 to 9 inches. In 2021, the global sea level set a new increase of about 97 mm. This shows you that the world is facing much more danger and is expected to face even much worse danger in the future due to climate change impacts. Also, on the Arctic Sea, ice, you could see a decline in size of this Arctic sea ice due to climate change with the increasing temperatures. And this is a statistic you could see the drop in this size from about 7 million square kilometer down to about 4.7, 4.6 in 2016-17. This shows you that there has been a decline, and this also has an effect in sea level rise. According to a NASA research, in September, Arctic sea ice is now shrinking at a rate of 12.6 degrees per decade, compared to an average extent during the period from 1981 to about 2010. Who knows what might happen in the next 50 years if nothing is done to stop this. So this shows us some of the basic sciences behind climate change, the formation of, or how climate change is coming about due to human activities, the effects of climate change, the global warming, the impacts of human activities on climate, and devastating impacts of the climate to some key parameters and how it affects humanity. And I believe this should set a very good understanding to you on the basic and what it entails on the sciences of climate change. For further reading, you could build more knowledge by following some of these links. They provide much more detailed explanations on the sciences, the statistics, the global trends, amongst others. I believe we have come to the end of this presentation, and I hope you have acquired as much knowledge as possible. Thank you for your time.